Hi there once again, and welcome to another Expresso Mechanic tutorial. And this is going to be a Python tutorial, and we're going to build another effector. And I'm calling this one a UFO effector for obvious reasons. We do have a UFO on the screen and it's flying around at random and crashing into various objects in the form of stars, moons and planets. And these are all dynamic objects, and I've used the follow position and rotation controls to actually make them behave in the way that you're seeing on screen. That's what we're going to be about in this tutorial. So without further ado, let's see if we can make this happen. We'll start by bringing in a star, and we'll leave it as it is with regard to the 8 points. That's absolutely fine. We'll make the inner radius 10 and the outer radius 20, and that gives us the shape of our star. We can then drop this into an extrude, so hold down the option key and drop that in there, and we'll make the offset 10, and in the caps we'll add just 1 centimetre of rounding, and if we hit over to see the object we can see that that's looking really quite nice. So that's our first object complete. Moving on from here, we can bring in a circle. If we just make this 20 in the radius, that makes it about the same size as the star, and that's perfectly good. Now if we rotate this through, let's have a look, see where we are. Do we want to rotate through 180 degrees? I think we do, really, unless, no, not necessarily a problem. I think we can get around this another way. So we'll make it editable. We'll go into points mode. We'll delete this point, and what we need to do, in actual fact, I will leave that point in. I think what we can do is just manipulate. If we just bring this over here, that looks good, but there's work to do. We just need to hard interpolate these. So in our spline, if we say tangents, hard interpolation, that's fine. That's got us some of the way to where we need to be. So we need to do a bit more work. We need to select all the points, so Command A, and hold down the Control key and click, and then we can select the subdivide menu. That's fine, that's given us some extra points. Select the top and the bottom point here with the shift held down, and then move this back. And that gives us a nice crescent moon sort of shape. That looks pretty good. I think we'll probably get away with that. I mean, we could do a little bit more manipulation with these spline points, but for what it is, I think that will do fine. So we can drop the circle now into an extrude. So hold the option key, drop it into an extrude. Once again, in the object tab, make it 10 centimeters, and in the caps add a centimeter of rounding, and that gives us a nice crescent moon. So that's all looking good. So we've got our first 2 objects complete. Moving on from here, we need to do some work with some planets. So we'll bring in a cylinder on this occasion. We'll put it in the orientation +Z, move it over here, and its radius wants to be 30, and once again the height we can make 10 so that it matches up with everything else, and that will be our larger planets. And then from here we can just select, well, we'll go back into model mode for what it is, select this, and we'll command click just to and drag just to create a copy, and then we can make this 20, and that will make our smaller planets, and that looks really nice. We can, if we so wish, add more rotation segments. We can make this, say, 30, just to make it that bit rounder. Same with this one, just make that 30. And that looks really nice. So we've got those 2, and we can think about working with our caps. If we just command click on the other cylinder, select the caps, fillet, and we'll make it a fillet of 1 centimeter so that it matches up with everything else. Okay, great. So we've got all of our elements for our galaxy complete, and they all look pretty good. So we'll name them. This will be Moon, Star, Planet 1 and Planet 2, and then we can just rearrange them in the order that we want them. So it will be Star, Moon, Planet 1 and Planet 2. Okay, that's fantastic. So we've got those ready. The next thing we need to do then is build our flying saucer. So that will be our next step. Once again, this will be made from a cylinder, so we'll bring one of those in. It's in the correct orientation. So in our object tab, what we'll do, we'll make the radius 30 because it doesn't want to be too big. I mean, there's just about the same diameter as our large planet is fine. And its height, let's see where we are. Let's just make this 10 for now. Probably a bit too much, actually. We'll probably go 5. And height segments, I'll make 3. I'm just going to switch to Garrow shading line so I can see where I am. And that's good. Let's have a quick look at that particular object. Is it good or is it not? No, I think we can go 2, actually. 2, yeah, 2 should be perfectly good. That should work. Now, the caps, we want 3 segments. Okay. So that's that done. The next thing to do is hit C and make it editable, and then we can start thinking about what we're going to be working with. So let's just go into polygon mode, and what we'll do is UL for loop selection and select both our 2 loops there, and then we can move them upward. So we'll just place this up here, and then we can think about what we're going to do next. So what we can do, if we UL to select our inner loop, we can just move this up to here somewhere, and what we need to do next then is do some manipulation. Now we can probably, if we go to edge mode, UL, and select this loop here, just drop this down a little bit so that it's about there, and we could probably even do the same with our polygons here, just drop them down a little bit. But now what we want to do is actually select our scale tool. We don't want to work with our y-axis, but we just want to bring this outwards to somewhere around here, and that's fine. Just till we get that difference in the Fong there is perfectly good. And then we can UL again, select this loop and I for inset, and we can offset by 1 centimeter and hit apply. We don't want to preserve groups, so we'll uncheck that. And that's fine. That gives us our windows for our UFO. And that's looking quite nice. The next thing we can do is work with the underside. So if we, once again, UL, select both of these. So I'll just shift click to select there. We can just move this down a little bit. Okay, that's looking pretty good. And then what I can do is UL, select the inner polygons and just drop those down there so that we get a nice rounded sort of shape at the bottom. That looks fine. That looks really good, actually. Yeah, that looks quite nice. Okay, I'm liking that. And what we could also do here, if we just select our middle loop here, and then we select our scale tool, we can just move that out so that we get a bit more sort of roundedness on there. And then finally, the one thing I will do, I think, is just do a cut around the top. So if I say KL for loop cut, I can just make one more cut here, and then UL once again to select the new polygons that have been created, and just move that very, very slightly, just sort of so that we get that kind of effect. And possibly we could actually do D for extrude and come, say, 1 centimeter, and then just, if we wish, we can just manipulate that out. And then, you know, that kind of thing is fine, isn't it, for a UFO? That looks good. It looks like a flying saucer. That looks really great. Now, I'm not going to be texturing any of this, but you can see that in my initial file here, obviously I have done some texturing, and I've created a texture for the windows and stuff like that. So, you know, there's probably a few more subdivisions in it, but it doesn't matter. And I've obviously got this top bit there. You can see that it's sort of a little bit more refined. But I mean, you know, play around with this to your heart's content. You can do whatever you like with it. But for the sake of just getting this thing done, I'm not going to go too far with the modelling. But, you know, this will do fine. As I say, if you wish to play around more with it, you can. Another thing you can do is just go into points mode, select this centre point, just bring that up a little bit so that we've got that sort of shape. You know, I think that's working fine for us. I think that'll do nicely. But anyway, that's our spacecraft ready to go. Our little flying saucer, that's ready to go. And we've got all our other parts. So that's great. It's all looking good. The next thing we can worry about is dynamics. And that will be our next step. Before we go any further, we'll just rename this. We'll call it flying saucer. Why not? Okay, let's just give that a capital S. Flying saucer. Okay, fantastic. Now, we'll work with the dynamics for this first. We want, in our bullet tags here, we want a collider body, because that's what it needs to be. And we need to have a quick look and see where we are. Now, in the inherit tag, we want none in there and off in the individual elements. The mesh, the shape, it won't be a static mesh. It will be a moving mesh. Now, the bounce and the friction. Bounce we can leave at 100%, the friction 5%. We don't want anywhere near that much. And that is really as much as we need to do with that. We can leave everything else the same and we don't need to worry about any of the other tabs. So that completes the dynamic setup for our saucer, and we've got things underway. Now, let's have a look at the elements. So, in our, well, I think in all our elements, let's have a look at this. Yeah, I think if we select them all, we'll just add, for a start, the bullet tags, so rigid body dynamics. And let's have a look and see where we are. Now, in the inherit tag, we can say we don't want anything in there, so none, and individual elements will be also none, or rather off. The shape, we can say convex hull. And then we can think about the bounce and the friction again, and we'll do the same as we did before. We'll have 100% for the bounce and 5% for the friction. Okay, the next thing we can do is look at the forces tab. Now, we're going to do this individually. So the star, we need to look in here, and we're working with follow position and follow rotation. Now, the follow position, we're going to give this 10. The follow rotation 5, and the linear and angular damping, we can leave the linear damping at 5%, but we'll make the angular 80%. Okay, so that's the star sorted out. That's perfectly good. Now the moon, let's have a look in here. So again, everything else we're okay with, but the force here, we're going to work with the follow position and rotation again. Now for the moon, we want a follow position of 10. On this occasion, a follow rotation of 30, because I found the moon can go a little bit crazy. So I'm putting this up to follow rotation. I'm going to give that a value of 30 to try and rein things in. Now, let's have a look and see where we are. So the linear damping we'll leave at 5%, and the angular damping will make 90% on this occasion. So that's the moon sorted out. Now, the planets, we can select both of these because they're the same. Follow position will make 10. Follow rotation 10. The linear damping we'll leave at 5 once again, and make the angular damping 80% once again. Okay, so that should, all things being fair, complete our dynamic setups. And the next thing to do is actually duplicate our heavenly bodies. And in order to do that, we're going to be using a cloner. So that will be the next step. We'll select these 4 objects and then hold down the Option and Command keys and select a cloner and drop them in. And we can see straight away that we're getting a clone of each and every one of them, or at least one clone of each and every one of them. But the cloner isn't set up as we need it to be. Now, in order to set this up, we need to bring in a sphere, and we'll make this 280 in its radius. What I'll also do is give this sphere a rigging, or rather render tag, and it'll be a display tag, and we will switch this on. So we'll use the tag and we'll select lines because we want to just see what's going on in the sphere. Now, with the cloner, we can just select this. Our mode will be object, and with the clones, we'll select random, and we can select the sphere as the object. So we'll bring the sphere into this field and drop it in here. And now straight away that we can see we're getting something different. We're not getting what we want though, because we don't want the objects to be distributed on the surface. We want the distribution to be volume. So we'll select volume. That changes things. It's got things a little bit better. Now, our volume mode will definitely be random. We want that, but our seed value, we'll change that. At the moment, we've got 1, 2, 3, 4, 5, 6, 7. We'll make this 1, 2, 3, 4, 9, or 5, 9, 3. So 1, 2, 3, 4, 5, 9, 3. And that will give us a little bit of a different distribution. And then finally, the count value, we can make this 35. Okay, so we've got something resembling this now. And we've got quite a good distribution. We can see that within the sphere there. So that's looking reasonably good. Now, the only thing we can do is play around with the actual order of our objects if we don't quite like having too many planets. So let's have a little play around and see what we can do here. If we move maybe this over here, we've got a slightly different distribution and we've got slightly fewer planets, and that's probably looking reasonably good actually. It doesn't look too bad to me. You know, we've got things in a reasonable position there. I think that's quite good. Well, we can play around a little bit more if we so wish. We could just move our second planet over here. I'm not too keen on that. I think I'll leave that where it is. And then finally, let's just see if we can move the star into the middle and see if that makes any difference. Not in a particularly pleasing way, so let's just put it beneath the moon and see if that makes any difference. Again, not particularly pleasing, and it's not particularly pleasing there, so leave it at the top. I mean, I think personally that's probably the best distribution out of all the ones that I've seen, and I'm going to leave that, I think, like that, and I think we'll actually go with that. I think that can work reasonably well. Okay, so we've got things sorted out there, and we've got the cloner pretty much set up as we need it to be, and we can leave it like that. I think that's okay. So that's the setup for the cloner. Moving on from here, the next thing we need to do is work with a matrix. So we'll bring that in as well. I mean, this sphere, we can make that disappear now. We don't really need to see it anymore. We can leave it where it is, but we don't need to see it anymore. We could take the tag off, but we'll just leave it for what it is. Okay, so let's bring in a matrix. Bring one of these in. And instantly we see that we've got 80 cubes on the screen there. We don't need that many matrices, but we'll just start working with the matrix to make it behave the way we want it to. Now, straight away, the mode needs to be object once again. And again, the object needs to be our sphere. We need to make the distribution on this occasion edge. And now we can see that we've got cubes on every edge of our sphere, and that's fine. That's brilliant. That's exactly what we want. And that's as much as we need to do. We don't need to change the generate. Matrices only is exactly what we need. We're not working with thinking particles, so we don't need to actually do any more with the matrix object. We've got it set up exactly as it needs to be. We don't need to see it, so we'll make it invisible, and that's fine, and it's ready to go. Fantastic. So we've got everything now in the scene that we actually need. And moving on from here, we can simply add, and we're going to be adding it to the matrix. We can add a Python effector and select full control. We'll go into a scripting layout and open in Python editor. And we're ready to start coding. Let's just manipulate this, just move this back over here so that we don't see too much of this particular pane. And then we're ready to go. As per usual, the first thing I will do is get rid of this for loop because we don't need it, and we can hit execute. We need to import random because we are going to be using random numbers. So, well, that's the first line of code that we'll enter up here. And then we can think about what we're going to do next. Well, first variable that we need will be the ubiquitous frame variable. So frame is equal to dot get time dot get frame brackets dot get fps open double close to get our frames from the timeline. For anybody who doesn't know, I'm sure you must all know by now. At least I hope you do. But anyway, we've got our frame variable in. we now need to define a few global variables. So global, and it will be start, finish, trigger, and finally start underscore time. Two of them you probably recognize, but the start and the finish you wouldn't have seen perhaps, but you'll find out what they do a little bit later on in the tutorial. We then need to bring in our saucer, our flying saucer here, because we need to work with this object. So we can define a variable. So saucer is equal to doc.search object brackets open single quotes flying saucer close single quotes. That's flying sauce. I've got to say flying saucer. Flying saucer. Okay, and that will bring our flying saucer here into this code so that we can work with it. So that's brilliant. We've got that. Now, the next thing I need to do with my Python effector selected here is go into our user data and add user data. And what I just need a spline. So I'm going to define that as spline. We'll just give it that title. If I can spell it correctly, spline, that's good. And then our data type will be a spline, obviously, so we'll just select that here. We can hit OK, and then in here we can add a couple of points. So one that's going to be in the bottom left corner, the other in the top right. We can then twirl this open and work with this, and we just simply want to say minus 0.25. And that's great. So we've got our spline set up, and that's what it needs to be. The next thing we can do is drag the spline into here. And as per usual, it's being placed in the wrong place. Let's just take that out of there and drop it in here. And we can define it as a variable. So we can say spline is equal to op C4D user data 1. And that creates our spline. Now, we don't need to worry about these two lines. We're not going to be using them, but they can just stay in. As I so often say, we can just ignore them really, just as long as we leave them there. And now we can think about where we're moving to next. Well, we can think about what we're going to be doing at the beginning of the animation. That's going to be the next port of call for us. So we can say, we'll just leave a bit of space, if frame is equal to 0, and then we can decide what we're going to do. Well, for a start, we're going to define all of our global variables. So start is equal to, and it will be an empty list. Finish, once again, an empty list. Trigger, and finally start time is also an empty list. So we've got those well and truly set up and ready to go. The next thing we need to worry about is where our spaceship or our flying saucer, where that's going to start, where its initial position is going to be. And that's going to be defined by a random value. So we can say RND for random is equal to, and it will be random dot rand int, so random integer, and it will be a value between 0 and 239. Now, how do I know that? Well, if we just come up to here and we print brackets, and we'll print this count value, this count variable here. So if we print that and we hit execute, don't worry about the error, that's not a problem. We get 240. So our matrix contains 240 matrices. Okay, so that's how I know that value. It's simply the count value minus 1 basically. So we can say random.randin, and it will be 0, 239, and that's going to give us the correct values, and we won't go above 239, so that's fine. That's what we need. We can then say if len brackets start is less than 1, start dot append RND. So we're going to place our random value here into our start variable or our start list. It will populate this list with a single number, and it will be this random number that's generated here. The next thing we need to do is basically a vector to reals. So its x is equal to, and it will be mar, so matrix array, brackets, and it will be start, brackets 0, double close. So whatever is in our start list here, we want that to be the index value for the matrix that we're going to be interested in. Okay, and then we can say dot off dot x. We can then copy this, paste it in here, and say y is equal to, and at the end, dot y. So we've got our x and y axes, and we finally need the z, so we can say z and z. So that gets the real values for our x, y and z positions. We can then say vect is equal to brackets x comma y comma z, and to finish this section off, saucer dot, and it will be set abs for absolute pos, so set absolute position, and it will be vect. So we're taking our vectors and our real values, we've converted them back into a vector, and then we're using the vector to set the absolute position of our saucer. So literally we're going to choose a matrix. If we just bring the sphere back in, rather the the matrix back in, we're going to select one of these cubes or one of these matrices as the initial start position of our saucer. That's what we're going to be doing. Fantastic. So that's great. Let's just make that disappear. And that's fabulous. So that should actually work if we just go back to the beginning, see if we get any result. We've got it actually. It's placed it down there. You can see what it's done it. If I move, then it places it there. So that's now working. So that section of code is doing exactly what it needs to do. Fantastic. So if we make a little bit of space here, we can define our one and only required function, and that'll be our next step. We'll start by moving up to here and saying def, and our function will be called move. Okay, so that's our first line. So what do we do next? Well, we've already created our start position for our saucer, but the next thing we need to do is create our end position. So our finish is what we're going to be working with now. So we can say if len finish, and it will be less than 1. As we did before, rnd is equal to random.rand int, and once again it will be 0,239, and we can then say if random, or rnd for random, is not in start, finish dot append rnd. So we don't want our finish to be the same as our start, because obviously if that were the case, our flying saucer isn't going to move anywhere. So that's why I've set this up the way I have. So we check to see if it's in start. If it's in there, then we're going to generate another random number, and we're going to keep generating random numbers until we get one that is not in start. That's what's going to happen potentially. Okay, so that's why we've done that. Moving on from here, we can say if len, and it will be brackets finish once again, is equal to 1. So if we've got a number in our finish list, we can then think about what we're going to do next. So we can then say if len trigger is less than 1, trigger dot append, and it will be 1. And as I always say, you can put any value in here, but I always go with 1. We can then say, and we're going to say this at the same level as this nested if here, if len brackets start underscore time is less than 1, start time dot append, and it will be frame. So we want the current frame value in start time. We can then come back to the level of this particular if, and we can say if len trigger is equal to 1, and then we can move on from here. Now this is where we start working with range mapping and also a monoflop. So first thing we can do is once again convert vectors to reals, or to be more precise, matrix to vector to reals. So we can say start underscore x is equal to, and it will be mar open square brackets start brackets 0 double close dot off dot x. We can copy this line and drop it in here, and this will be on this occasion start dot y, and over here dot y, and then once again over here we can say z and z. So that's our start positions. This is what we're working with here. So we're working with our start positions. We then need to work with our finish positions. So we can say finish underscore x, and once again it will be equal to mar open square brackets, and this time finish open square brackets 0 double close dot off dot x. Copy the line once again, and we can paste it in finish dot y dot y, and finally we can paste again and make it finish dot z, or rather finish underscore z, and dot z at the end. So we've got our real values for both our start and finish x, y and z axes. The next thing we can do is work with our monoflop and range mappers. So we can say duration is equal to frame minus start time, so if I can spell it correctly, start time brackets 0. So whatever frame we've grabbed into our start time, we're going to subtract that from the current frame, zeroing things out on the timeline and then working from that point onwards as we do with a monoflop in Expresso. We can then say if duration, and we'll say less than 30. So we'll do this over 30 frames or 1 second. So that's what we're going to do. Our spacecraft is going to move over 30 frames. So if duration is less than 30, we can then think about our range mappers, and we can say range mapper x is equal to c4d.utils dot range map brackets duration, spell it correctly, duration, comma 0, comma 30, comma, and it will be start underscore x, comma finish underscore x, comma, and it will be false because we could be working with negative values, and then finally comma spline. And that gives us our range mapper X. Oh, actually, I've got a capital X in there. I just want to make that a small one. Just do that. So that's our X range mapper worked out. We can then copy this code and place this here, and then change the X's to Y's. Paste again and change the X's to Z's. And that's our 3 range mappers worked out, one for each of our axes. And they will enable us to move our spacecraft from point A to point B, or from matrix A to matrix B, if we want to look at it that way. Okay, fantastic. So we've got that far. The next thing we need to do then is create some real values from our range mappers. So we can say X is equal to range mapper underscore X. Again, we can just copy this. So copy it and paste it in, change the X for a Y, paste it in, change the X for a Z. And we've got those worked out. As we did before, vect is equal to X, comma, Y, comma, Z. So we've created our vector from our real values. And as we did before, we can simply say saucer dot set abs pos brackets vect, and now our saucer will take these values, or this vector value, and basically move from point A to point B based upon what's going on in the range mappers. We can then come back to the level of our if here and say else. And this is where things get a little different to what we normally do. Basically, once we've done one cycle and our saucer has moved from point A to point B, we then need to store point B as the new start position, because it needs to go from here to here, then from here to here, here to here, or whatever. So we then need to say start brackets 0 equals, and it will simply be finish bracket 0. So our current finish position during this cycle becomes our new start position. And that's why here we just work with our finish. We never need to worry about the start anymore. We only do that at 0. We only worry about that here. We don't worry about it with move, because we always set the start position to the finish position, or the previous finish position. That's what we're doing. Okay, so that's taking care of that. Once we've done that, we can clear this finish list. So finish dot clear, that completes that, and then trigger dot clear, and finally start time dot clear. And that sets everything up for the next cycle. And that's as much as we need to do with our code. That's the function here, the move function, complete. So in order to make this work, we've got to call that function, and we can do that after our if statement here. We'll do it at the same level. We can simply say move, open, close, and that completes the code. So if I haven't made any mistakes, it should work. So let's give it a go. Well, yeah, we can see that it is. Our saucer's moving around, isn't he? That's great. Fantastic. So what we need to do, we give this 1,000 frames so that we can actually give it a fair go. Set back to 0. We've got our start position. It's down here. I'll tell you what, let's just make the saucer a little bit more visible. Let's just give it a colour. If we go into our material here, automatic, and we make this yellow, just give it that colour so that we can see it more easily. Did I select the saucer there? I did, didn't I? Yeah, okay, we can just about see it. It's not fantastic. I'll tell you what we'll do. Let's just go back to our standard view for a minute. Now we can see it a little bit more visibly. There it is. So if we run the timeline, we can see it zips about and it crashes into things and they move around exactly as we want them to. So yeah, it's working. Fantastic. And you can see that it literally moves. Well, it moves pretty much the way people often describe a UFO as moving. So it works actually quite well. But yeah, I mean, that's all there is to it. It's quite simple, really, quite a simple idea. But the thing is, I think it was important to show you this because you've never seen me create an effector that works with a matrix. What we've normally done is worked with manipulating clones within a cloner. On this occasion, we're kind of doing the inverse of that because the clones are not being manipulated in any way. They're just being set up in the cloner and just left alone. And we're using the matrix to simply call in an object from here and then move that around based upon the positional data of the various matrices contained within the matrix. So it's a different way of creating a Python effector and a different use for it. But yeah, I mean, that's basically what we're here to do on this occasion, and it's working really quite nicely. So yeah, that's the way you create a UFO effector. And yeah, it's hopefully been quite fun doing it. But if we take a look at my original file, I mean, you know, it's just to perhaps give you some ideas. I mean, all I've done, I mean, you're probably texturing wizards, some of you, so I'm not the best at texturing, but you know, all I've done here, I mean, I've just created some very basic textures. These couple here, they've got, if we have a look at them, I've got colour, I've got luminance and a little bit of reflection in there. The luminance is just to make them look a little bit like stars, and the blue one here is applied to the moon. The texture here, again, it's a similar type of texture with a little bit of luminance in there. That's just applied to the windows of the spacecraft just to make it a little bit more interesting. And I've got a basic white here that I've put on the actual spaceship just to give it a little bit of colour there. And then the planets, I mean, I've just mainly used noise. That's what I've done here. I just put a noise in there and just change the colours accordingly and add a little bit of a play around with them just to get them to where I wanted them to be. You know, that's all I've done. There's nothing particularly clever going on with any of this stuff. It's perfectly simple. I don't quite know why that's suggesting that's, hang on, it's just going to there. That's it, but I did a different channel. That's right. So it is, yeah, it's just sort of a pinky colour and a browny colour for that particular one, for the small planets. And then this one here, if we go into the colour, we can see that it's just blue and green, and it's, you know, sort of Earth-like, I suppose, like a bit of an alien sort of Earth. But that's all I've done there. I've just kept it very basic. I mean, if you know, if you're a texturing wizard, then, you know, do something much more interesting. I'm sure you can. And then also what I did, I put a background in, and if we just take a quick render of that, it just places a star field around it, so that it just sort of gives it the idea that it is somewhere in the universe, you know, in a sort of cartoony sort of way. That's all I've done with it. But yeah, I think it would look quite effective if it was rendered out. You know, it looks quite nice. But anyway, that just about brings us to the end of this tutorial. So as always, I really hope you've enjoyed doing this one and that it's been quite fun to do, and that you've picked up some techniques that you may be able to incorporate into your own projects. And if you have enjoyed the video, please give it a like, and if you haven't already, then please subscribe to the channel, leave a comment, and of course ring the bell. And wherever you happen to be on social media, please do share this video, because all this good stuff really does help keep the channel moving in the right direction. But anyway, that just about brings the curtain down on this one, so I'll see you very soon on the next tutorial.